Hey, welcome back, everybody. Um, so I haven't graphed mine yet. Yes, Miss Oak hasn't done her homework. The reason why is I was thinking of showing you a slightly different way of doing this, and that's with the mapping notation. Um, and you might be interested in that. So vertical stretch, and not just interested, it's something you need to know how to do. So vertical stretch by factor of 2, um, instead of rather thinking uh, taking that point, well, we're literally going to do that. If we're going to stretch that point vertically by factor of 2, say this point here, it would go here, right? Negative 2 would become negative 4 because you multiply the y coordinate by 2. Well, guess what? In the mapping notation, so if we start with x comma y, if we multiply the y coordinate by 2, that would become 2y. There we go. That's the new generic point. Okay, if we reflect over the x-axis, so let's see this. If we took this point here and reflected it over the x-axis, it would now be here. So what changed? Our y went negative. Okay, so if I scoop y out and put in negative y, that essentially makes that point negative 2y. Okay, so that's what happens after each of these transformations. Right 3, if I move this point right 3, I would end up here, and really what I did was I added 3 to the x-coordinate. Negative 3 plus 3, I got 0. So if you take the x-coordinate and you add 3, that would move the point right 3. Okay, up 1. So if I now move that up 1, I've added 1 to the y-coordinate. So this would now become, and we have to, actually, no, you just add y, or add 1 to the existing y-coordinate. So that would become negative 2y plus 1. You don't scoop y out like you would with the equation, because this is just simply a point and it works normal. So if we had negative 2y as our coordinate, you would add 1 to it on the graph. Okay, so what we could do with this now is we can set up a little table with our points. So we started, this point was negative 3, comma, negative 2. And if we do all this to that, we'd have negative 3 plus 3. I'm putting it in for x. Negative 2 times negative 2 plus 1. What do we get as our point? 0, comma, 4 plus 1 is 5. Look at that. That's where it is. Okay, that looks really good. So why don't you guys pause your video, try this again, and take all those original points and do this mapping notation to see if you get the graph that you may have drawn already, okay? It's really good practice to do this, and there could be a quiz question on it, okay? So pause your video and let's do that. Okay, that was not an easy one to connect the points, was it? Okay, so here's what I've done with all of the existing points. I've used my key mapping notation that I created from these transformations, and I basically subbed in my x and my y coordinates into that to get new points. So here's all my points that are on the transformed graph. Plotted them, connected the dots, and there we go. So hopefully you guys got the same graph that you did originally, but this is an important thing to know how to do. Okay, example number 3. Consider the function y equals f of x. In each case, determine the replacements for x and y, which would result in the following combinations or transformations. The equation of the transformed function in the form blah, blah, blah. Okay, so the horizontal stretch by a factor of 1/4 about the y-axis. So they want the replacement for that. Horizontal stretch. So horizontal means x is going to be replaced with. Okay, now it's a stretch, so that means the number is being multiplied by x, and stretch factor 1/4 would get reciprocaled, if that's a word, to be 4x. Okay, now vertical translation, 5 units down. So vertical, we're talking y. Okay, and if we're translating it down, that's when we take y plus or minus something. Okay, now it's opposite because it's with the letter it applies to. Down, you'd think minus, but it'd actually be plus 5. Good, so we're starting with y equals f of x, and we're going to replace y with y plus 5, and x with 4x, and that would be good. This is a good answer. But if they wanted as y equals, we would then subtract 5 to the other side. Do not go inside the function, the brackets, and the minus 5 would be out here. There we go. Okay, you guys try the next one. It's got an extra little reflection involved, so remember reflections are negatives unless it's in the line y equals x. That's when you switch x and y. So you guys try that one. We'll see if we could get the same answer. Pause your video now. Okay, so our replacements, stretch of 3/5 should be y is replaced with 5/3 y. X, the reflection in the y-axis, imagine this, so x would go to an opposite value. So x is replaced with negative x, and left 2, so x is replaced with x plus 2. Combining those two transformations, that would give you x being replaced with negative, then do the translation brackets x plus 2. So we do the replacements, we isolate y, which means dividing by 5/3 or multiplying by 3/5 on both sides. And there we go, that would be our answer. We could multiply the negative through as well, so if that happens to be a multiple choice answer, it would look like this, negative x minus 2. Okay, so if you see that answer, that also would be equivalent to negative brackets x plus 2. Okay, let's look at the next page. Okay, so we're taking a function g of x on example 3 here, and g of x is equal to x cubed. And you know, g of x, f of x, p of x, whatever it is, that's just y. So you can think of that as y equals x cubed. Okay, and it's transformed into a new function p of x. To form the new function p of x, don't worry about the p of x yet. We'll throw that in at the end, okay? G of x is stretched vertically about the x-axis by a factor of 0.25. So the replacement for that, vertically, so y, stretched, so we're multiplying by y, by factor of, oh, that's not a good factor to have. That as a fraction is 1/4. And if you're not sure about that, you can go on the calculator, 0.25, math fraction, enter. Okay, so we have a stretch factor 1/4, which means reciprocal that, and we would get 4 in front of the y here for our replacement. Y is replaced with 4y. Okay, then what have we got? Oh, reflected in the y-axis. So reflected in the y-axis, x goes negative, and translated 3 units to the right. So x gets replaced with x minus 3. And again, let's combine these two x transformations. So x would be replaced with first the reflection, then scoop it out and do the translation of x minus 3. Okay, so let's just start with y equals x cubed, okay, up here. And we're going to do our replacements. And if you want to pause the video to see if we end up the same thing, feel free to do that at any point during this video. So 4y equals, and I'm going to use square brackets here for replacing because we have another set of inner brackets. And there we go, divide both sides by 4, which means we'd have 1/4, negative bracket x minus 3 cubed. That cube's on the outside. Okay, now we could simplify that a little more because this negative is being cubed. So negative 1 cubed is going to be negative 1. So 1/4 times negative 1 and then times x minus 3 cubed would give you negative 1/4 x minus 3 cubed. Now, at this point, we want to replace y with what they called it, which was p of x. And there we go. P of x transformed from g of x. All right, example number 5. Given the graph of y equals f of x, sketch the graph of the transformed function y equals f at 1/2. Now they give you a hint here. Rewrite this function in the form. Okay, so what are they getting at? Take a look here. That b, that horizontal stretch factor, on the form they want and the form we should have, is not outside brackets in front of x. It's actually immediately in front of x. So guess what? Your first step would be to factor it not outside of f, but just away from the x a little bit. That means when we factor that out, we have to divide it out of the 3. So 3 divided by 1/2 would be 3 times 2/1 multiplied by the reciprocal. So that would become a 6. So it would be 3 plus 6. Okay, if we had factored out a negative, it would have changed the sign as well. Okay, and then minus 8. It seems weird that a number got bigger when we divided it, but that's what happens with fractions. Okay, so now we have our equation. I would like you guys to do this one completely. First, write down your transformations, and I would take a point x comma y and come up with the mapping notation for this one. Okay, let's practice that. Um, so just to start you, you're going to have a horizontal stretch, and I'm not going to tell you anything more. And then you're going to change the coordinate. And then you're going to take each of these points and use that final transformed mapping notation. All right, that's the plan. Go to it, pause your video. Hopefully we get the same answer. And make sure you graph your video after. Okay, pause your video. Okay, how did we do on this one? Check out these points, see if you got the same transformed points. You probably thought you were doing something wrong when you went to graph it, because we end up with a point way down here at negative 12, negative 12. So no, you didn't do anything wrong. Just weird, they should have extended the graph on that one, but it's all good. Hopefully we got the same graph, and we can label that y equals f 1/2 x plus 3 minus 8. And there we go. Good. Example 6. Our last example, the function f of x equals the square root of x has been transformed into the function g of x equals negative 2, blah, blah, blah. Complete the following statement. Okay, so first of all, always, always keep your eyes open for this. This is a trick guaranteed to be on our tests as well as the diploma. See that 3? Okay, if we want it in that standard form that they give us a hint about it on the last question, that 3 needs to be not immediately in front of the x. Because guess what? The translation here is not right 12. Okay, so you need to factor that out. It doesn't come outside the root, okay? And so I'm going to let you do that. I'm not going to do that for you. In fact, I'd like you to complete this whole question, and then we'll check back and see if we have the same answer. Okay? All right. Good job, everyone. And pause your video now. Okay, so we factored that 3 out. 12 divided by 3 is 4, so we have 3 bracket x minus 4. Okay, and then we are asked to fill in these blanks. So it's stretched horizontally, so that refers to the number in front of x, right? X horizontal, and it's with the x, so we want to reciprocal that to get our stretch factor, 1/3. Stretch vertically, so we look at the number in front of the whole function, okay? Used to be over there with y, but that's okay. When it's over here by itself, it works normally, so it'd be stretched vertically by a factor of 2. Not negative 2, okay? The negative is another transformation, which is the reflecting in the x-axis. When you have negative in front of y or in front of the whole function, that's reflected in the x-axis. Okay, finally, translate 5 units up and 4 units. Okay, we would have got that wrong had we not factored out the 3. 4 units to the right. Okay, x minus 4, opposite of what do you think? So that would be to the right. All right. Good job, everyone. Hopefully, by now, you know everything you need to know about transformations. We're going to practice, practice, practice. You're ready to do this assignment, lesson 8, and then we'll get you ready for the unit test. Okay, good job. We will see you in the next unit, or listen to me in the next unit.